All right, so let's continue with our next lab, analyze data with Apache Spark in Fabric. This lab will take you approximately 45 minutes to complete if you're unfamiliar with Microsoft Fabric, but if you're familiar with Microsoft Fabric, it will take you considerably less amount of time. So let's take a look at how much time it will take us. Let's go to the first task, which is create a workspace. To create a workspace, we're going to navigate to the left menu pane we have here and look for workspaces. Click on that and then click on plus new workspace. Let's give this workspace a name, DP-600 Lab 4, and click on the advanced section and make sure we have either the trial fabric license or the premium capacity license or the fabric capacity license selected. Click apply. Now that we have our workspace created, let's go to the next task where we're going to be creating a lakehouse and uploading some files. To create a new lakehouse, let's click on the plus new item button and look for the lakehouse, which is under store data. Let's give our lakehouse a name, DP-600 Lab 4, and select create. All right, so we have now our lakehouse created. Then let's go ahead and download these data files from this zip file created for us. I've already done this prior to starting this lab, and I have a folder which has 3 CSV files, which is 2019, 2020, and 2021. So let's continue with our lab where we're going to select the 3 dots and select upload and upload folder, not files, upload folder. And let's look for the folder that we have, which is called orders. So I'm going to upload the orders folder. And that orders folder has 3 files, 2019, 2020, and 2021. There you go. Now our CSV files are uploaded. Let's go and take a look and make sure that they are there. And there you go. We have our 3 CSV files. For the next task, let's create a notebook. So let's go back to our workspace and click on plus new item and find the notebook item, which is under get data section. We have the notebook. All right, so now we can change the name of this notebook, for example, analyze data, because that's what we're going to be doing in this section. We're going to be analyzing data with Spark. And we're going to be using this notebook for some data exploration. So I'm going to copy the code from here, and I'm going to be replacing this with the code that was provided. But also, we're going to change this cell to a markdown cell. There you go. So now I have a huge heading and then some text below that heading. Okay, looks good. Now we're going to be creating a data frame. So in order to create a data frame, we are going to be connecting to our lakehouse in this notebook. So over here, I'm going to add a notebook and select an existing lakehouse without schema, the one that we have already created, which has the name DP-600 Lab 4. There you go. It was just a bit slow. And now I can add it to the lakehouse to my notebook. Or we can go to the lakehouse and click on Open Notebook from within our lakehouse and select an existing notebook. And we're going to select the Analyze Data notebook that we have. And there you go. Now you can see we have the lakehouse connected to our notebook. Give it a second, and now we can also see the files that we have ingested recently into our lakehouse, which is now available even in our notebook so that we can use it. All right. So now for this 2019 CSV file, what we're going to do is we're going to click on this three dots for the CSV file and load data and load it to Spark. What this is going to do is it's going to automatically create some Spark Python code, PySpark code, which we can just execute, and it will create a data frame for us only from the data from that one CSV file. So now that I have run this PySpark code, we have the session started in 7 seconds, and now we have the session ready. And in 17 seconds, we have run and created this Spark data frame, and we have also displayed the Spark data frame in this cell. All right. Now, let's take a look at this code. And we need to modify here the option header is equal to true to header equal false. All right, because it's, as you can see in this file, the header information is actually data from the file. So what we're going to do that, you can see in this, we're saying option header false, and the rest of the code looks the same. So that's what we have done right now. And let's run this again. All right, now you can see the data is completely in the rows, but we do not have any column names. Now, in order to get some column names, we're going to create some schema. Let's do that in the next cell. We're going to copy the code we have provided for us over here, which is creating for us some order schema, where we're going to give the data type and the column name for each column in this data frame. So let's run that. And now you see we have the header names and the data types for those columns correctly assigned for all the columns. All right. Now, this data frame actually only has data from the 2019 CSV file. What if we want to get all the data from all the three files into one data frame? Then we can use a wildcard character. We can do that by copying the next block of code, and I will tell you where the difference is. The difference comes right here. Instead of 2019, now we're saying it is star or the wildcard character .csv file. Because all the CSV files are in that orders folder, we don't care about the name of the file as long as it's a CSV file. We want to read it, and we want to get that data um, into our data frame. All right, there you go. Now we have data not only for 2019, as you saw over here, we had only 2019 data. Here we also have 2021 data. All right, so that's all 3 years of data. All right, so we're done with creating a data frame. Now let's explore the data in the data frame. We're going to add a new code cell. All right, and we're going to add this code now. Okay, what does this code do? It selects only two columns, the customer name and email from our data frame. And then we're going to print the count of customers and distinct count of customers as well. So let's execute that code. All right, so here we have the total count of customers, the distinct customers that we have, and the distinct customers itself, right? So these are all the distinct customers that we have in our data frame. And with this, we've also created a new data frame called customers. All right, let's copy this code. And this is another way of achieving the same code that we have done above, which is instead of df open square brackets, the name of the two columns, we say df.select and give the names of the two columns. It gives us the same result as this statement right here. All right. Okay. Now we're going to modify this code, and we're going to add a where statement after the select statement. This where statement is basically filtering for a particular category. So I want to filter for item is equal to this particular category. So let's run this. You can see the numbers are way different because now we're filtering for one specific item. So it's one specific item that was bought by different customers, customers that have bought the specific item. And you can see the distinct customers 133, total customer count is 133, or total number of times this item was bought is 133 by different customers, and the distinct customers that bought it are also 133. So every time this item was bought, um, it was by a different customer, right? Okay. Now let's aggregate and group the data. Let's create a new code cell and copy and paste this code in here. So now what we're doing is we're selecting item column and quantity column, and we're grouping by item, and we're doing a sum of that column. So it's going to be the sum of the quantity, right? Sum of the quantity that we're doing, because we have only selected item and quantity. If there were more numerical fields in here, then it would have done sum of those numerical fields as well. All right. Let's run this one as well. So in this one, we are trying to get the yearly sales. So we're going to basically, first of all, select the year, and then we are going to group by year and order by the year as well. So now it gives us the number of orders that have taken place every year. The import statement over here allows us to use functions like call, for example, um, and also alias, um, but mainly call and year, for example. Okay, so these are some of the functions that we can use from the SQL functions library, Python library. All right, now we're going to use some Spark to transform data files. For that, we're going to add another code cell to the notebook, and we're going to copy and paste this code. So in here, we're going to be, first of all, creating a new column called year, month, and then we're going to be creating new first name and last name columns by splitting the customer name. And then we're going to filter and reorder the columns, and then we'll see a short display of the first five records of this transformed data frame. So this is what it's going to look like. We have now the year and the month, the first name and the last name, and then we have the rest of the columns. Okay. And now we can see that the output is all good. Now we can save this transformed data. Let's copy the code to save the transformed data. So to save this transform data, we're just going to do a data frame name dot write dot mode overwrite and then the location where we want this data to be saved. So here we are going to be creating a new folder called transform data that as of yet doesn't exist. You can see in files we only have a folder called orders. Once we execute this, it will be creating a new folder called transform data where we will be saving our data. So let's run this. All right, transform data is saved. You can see we still can't see that here. So let's refresh the file section of our lakehouse. And now you can see we have that transform data and we have the orders folder. And if we open up that orders folder, we have the data now saved as a delta table. All right. Let's see if we can read this orders data. I'm going to collapse the lakehouse again. And now we're reading from the location where we just saved our data. And this is what our data looks like after it was transformed. We added the year and the month and the first name and the last name, and all is good. Next section here is going to be saving the data as some partitioned files. So let's create a new code cell and we're going to copy that code and paste it in the code cell. Here now we're going to take advantage of this new columns we have created, which is year and month. And we're going to partition our data by the year and then by month. And we're going to save it in a new location called partitioned data. So let's run this. All right, let's take a look in our lakehouse. I'm going to refresh this before we open it up. And we should have now a partition data location. And if we take a look inside partition data, you can see we have three different columns of three different partitions. And if I go into one partition, for example, I will see all the different months of data that we have. I can also open this for the month of 2020 over here, and I can see it's partitioned and it has a folder or a partition for every month of 2020 and the same for 2022. And that's the output of our partition data. If we want to read only a particular section of this data, let's try to do that. I'm just going to paste this code here. So now we're trying to read only the 2021 data. So here we can basically go for only that location, and we're putting a wildcard character in the star in the month because we want all the months of 2021. So if I read that, um, that should give me the output for only 2021 data here. All right. The next task is then to work with tables and SQL. So for this, we are going to first create a table. So let's create a new cell here. And let's paste this code. We're going to be creating a new table called sales orders. As you can see, our lakehouse doesn't have any tables yet. We only have subfolders in our file section. So let's run this right now. All right. And we have first of all created a sales orders tables, and then we have executed the SQL command describe extended on that table. and this is the output for the description of this table. Now, if I want to see that table appear here in the table section, I just have to click on refresh, and I have this new sales order table that we have just created. All right. All right. And now we're going to execute um, some more some more code here, but instead of just copying and pasting this code, what we're going to do is we're going to go to the three dotted menu for the sales order table and say load data to Spark. And it automatically creates this code, which is very, very similar to the code provided to you over here. See, over here it says your lakehouse dot sales orders, but we already have that populated for us over here. And then I can just run this code. And this code is actually using the Spark SQL library to embed a SQL query against my sales orders table. All right. We can also run SQL code in a cell itself. So if I create a new code cell here and copy this code, I'm using here something called a magic command, which is two percentage signs and then the keyword SQL. And you can see that this cell is actually a Spark SQL cell. Where all the other cells were PySpark cells, this is a Spark SQL cell because I'm using that magic command. So I can just execute this cell and it will give me the result of this SQL command. And for our final task for this exercise, we're going to visualize some data with Spark. So let me just copy this code and put it in a new cell block and execute it. And here you can see we always get the table as the output for any code that we have executed. But we can also create a chart. All right. So here we have a chart created, but we can always go back to the table. Here we have a chart. And in this chart now, I can edit the chart. So I'm going to customize this chart. Let me see if I can find it. No, that's for, let me delete that and do it again. Chart 2. Let's build my own chart. There you go. Now I can look at the chart settings. And I'm going to choose my chart type to be a bar chart. And here we can add a title. Let's select the x-axis, which is going to be the item, and the y-axis, which is going to be the quantity. All right, there you go. We have something showing up there. And I'm going to select the aggregation to be sum. And I do not want a series group here. All of that is fine. Stack is unselected. Position is right. I can have it bottom as well, for example, or top. Oh, this is the position of the legend. I don't need to see the legend in this case. And that's it. I have a neat graph created with the sum of the quantity of items sold per item. And this is how you can create a new chart. You can see a chart is supposed to look similar to that. We can also create some visualizations using code, using the matplotlib Python library. For example, we can run something like this, which will give us the values. So we can use these values now in a matplotlib code. So let's do that. So I'm going to be using this df spark here to convert it to pandas and then run matplotlib over that data. And there you go. We have these three data points now in a neat looking chart. Let's do some more visualization. Just going to copy paste this next line of code. We're just adding some more details here, titles, labels, grid, X text. So it makes it look a little bit better. Add some color in there. There you go. Now your visualization looks much better. And for the final touch, we're going to add some figures as well. Let's run that. Okay, now you can basically change the size of your graph once you create a figure with the figure size, for example. And then if you want to create multiple figures or multiple subplots, you can also do that with the figure element. So here, for example, I have two plots in the same figure because I've split that figure into two. All right. That was using the matplotlib library, but we also have something called a Seaborn library, which is also a Python library for visualizations. So I can use this over the same data. There you go. Now you can see the same data for the 3 years. And let's modify it a little bit to set some themes and make it look a little bit nicer. There you go. I have a white grid in the background. And for the final thing, let's modify this code again to set another color theme. Or another graph, a type of graph, which is a line plot. And you can see now we have a line plot. And with that, we are done to the end of this lab. And thank you for watching. I'll see you in another lab.